Hello everyone. This is the second video in the series of Edexcel statistic videos, which can be used even by other boards and if you want understanding on statistics. And this video is based on the basic statistical measures, which can be mean, median, mode, range, interquartile range, and standard deviation and variance. So let's straight dive into the topic. But before we start discussing the topic, I would like to remind you that there have been a lot of signups already, and we are waiting for more signups for our course. And we would request you that you make your sign up as soon as possible, as we are going to close them after a certain number of signups are there, as we want to maintain our quality. Thank you. So let's start with statistical measures and let's straight dive into the topic. So yes. So when we talk about statistical measures, there are three most important ones which come into our mind, and that is mean, median, and mode. Right? All of them are averages, but they are used in different ways. And we are going to do a simulation right now in collaboration with FED, and then you will be able to understand this better. Right? So all three of them, they give you some kind of an average, right? Mean is an overall average which considers all the values, right? And we sum up the values and then divide by the number of values, right? We will discuss this in detail later. Median, on the other hand, that is the middle value in the ascending order. And mode is the most repeated value. And all of these are the measures of central tendency. Now let's move towards our simulation. Okay, now as you can see over here, we have used a simulation to explain you the difference and how with different values the mean and median acts, right? So let's kick one ball and let's see what happens. So as soon as we kick this ball, now this ball actually goes on the value 10. Since there is only one value right now, so 10 divided by 1, your mean would be 10. And there is only one value, so one middle value, which is 10. Right? So at this point, since there is one value, the mean and median both are same. Let's kick another ball. Okay. That was a huge shot. So as we kicked the other ball, that went to 15. And now you can see there are two values. Still, you will get the same mean and the same, you're getting the same mean and the same median. And why is that so? Because it is kind of a, it's not kind of a, it is an exact normal curve. Because the distance from 12.5 to 15 and 12.5 to 10, it is equal. That is 2.5. So there is a distance of 2.5, right? And since there are only two values, we get the same median and the same mean, right? Now let's kick another ball. Okay. Now here, as we see, this ball goes at 5. Again, these distances are same, 5 to 10 and 10 to 15. It's again a normal curve, right? I can draw it for you. It's again a normal curve, right? And so, again, our mean and median is same. Now, let's kick 5 balls together and let's see what happens. Now, this is the kind of data we are actually getting. Now, look, the mean and median both are different. Obviously, we will calculate, through calculation, we will get different values. But here you need to understand why are the different values caused. If you can see, the mean is lower than the median. And why is that so? It is because of this value, which is a little unique. It is on the lower side, right? And it is actually stretching the mean to become low, right? So this value of 2, most of the balls, they lie in this region. You can see that 5 balls actually lie in this region and only 3, below 9, right? So why did your mean value actually become 8.9? That is because of one value which was a little peculiar, right? So that is one disadvantage of mean, that it can get dragged because of these kinds of values, right? Uh, there won't be any difference on your median because of these kind of values, because you're not considering all the values in mean, right? We will discuss this in detail as well. Okay. So I hope this simulation actually helped you to understand the difference in how these averages come into work. Now, obviously, if you have very peculiar values, which are stretching the mean, you would not want to use mean in that case. You would want to use median or mode in that case, right? Median rather, because, median actually has the tendency to overcome that kind of an error. Mode, on the other hand, it is possible that, your peculiar values occur in large quantity, right? So it can be a mode as well. That is possible. So median in this case works best. Okay. Now, what are we going to do? We are going to move forward with the topic, right? So let's move towards the presentation again. Okay. Now, we have discussed this. Let's move forward. Okay. So we had a little discussion on this. Mode is the value which occurs the most often in the data set. And when you have a frequency table, right, which has a range of values, a group or a class of values, that would be referred to as the model class. And if there is more than one mode, so that data set is basically bimodal, right? Bimodal. And why is it bimodal? Because obviously bi means 2, right? Median is the median value when the data set is in the ascending order, right? If there are 2 middle values, what do? You find the midpoint. And how do you find midpoint? Value 1 plus value 2. The sum of these values is divided by 2. Now, if you find the median from the frequency table, what do? It's important that you find the cumulative frequency first, right? So we will do this once we do cumulative frequency, and then it will be done in our future videos. And then we are going to find the group or class where the middle value lies. Okay. And if you have a group frequency table, you need to do linear interpolation. This would be again done in our future videos. Today, we're just going to look at it with simple data. And then mean is the sum of all values divided by the number of values, right? There are mean estimates even, when you have classes of data. Again, we are going to look at that in other videos, right? Okay. Now, you need to understand some kind of summary statistics, right? Notations which we are using. Now, this is, for instance, this is your sigma x. Sigma means finding the sum. X bar represents, we are trying to find the mean, right? So these are some kind of statistics which you need to understand, okay? Let's look into a question and we will find the mean, median, mode, and range, as well as we are going to find through this data only. We will look at variance and standard depth. Okay, so let's find the mean. Okay, in order to find the mean, what do we need to do? Wait. Right. Okay, mean. We need to find the sum of all the values divided by the number of values. There are 6 values. The sum would be 23 plus 19 plus 14 plus 28 plus 27 plus 19 divided by 6, right? This is how you will find your mean. So their sum is 23 plus 19 plus 14 plus 28 plus 27 plus 19. That is 130. 130 divided by 6, that is 21.67. This is your mean. Right? Now let's work towards variance and standard deviation. Right? I'm covering this also for simple data in this video. Variance and standard dev. Okay? Now, variance and standard dev is not an average. It actually measures the spread of the data, how much your data is spread from your mean, okay, around your mean, right? So it measures how far away the data is, right? How far away the values are spread, okay? So let's look at that. There is a very easy way to look at standard deviation. What you do is basically from each value, each of these value you have to subtract the mean, right? So that will tell you the difference, right? That will give you the difference, okay? So let's do that. So 23 minus 21.67. So obviously I'll be able to take out an estimate because I haven't taken the fractional value of mean, but you can always do that, right? When you have the calculator. So that is 1.33, right? Then 19 minus 21.67. Now, the sign really does not matter in these cases. Why? Because you need to square these values. When we do the next step, you'll understand that better. But right now, what I'm doing is I'm subtracting the mean from these values. So I'll just write the sign, okay? Minus 2.67. 14 minus 21.67. Okay, that is minus 7.67. Okay. And 28 minus 21.67. That is 6.33. 27 minus 21.67, that is 5.33. And 19, we already wrote minus 2.6. Right? We have all these values. Then what do? You square these differences. Okay? You have to square them. Right? Once you square them, then you add them. You sum them up. Sigma. Remember? Okay? So you will add them. And then you're going to divide it by, now if it is a population, we have already discussed population and basically sample in the previous video. If you haven't watched that video, you need to go to that video first to understand what is population and sample, right? If you haven't watched it, it's even pinned here, so you can click on it, right? So you need to, if it is population, you will divide it by the number of uh, uh, basically the number of units. Otherwise, you're going to divide it by n minus 1. And n is the number of units, right? Basically to count for degrees of freedom, right? So here we will consider this is the population. So we are going to divide it by 6. Okay? Right? So you need to watch that video if you have it. Okay? So 1.33 square. There's a lot of calculation involved in this to be done. So I'm doing it on 5.33, 2.67. Okay, and then divide by 6. Also, you people should tell me the answer in the comment box, right? For this. But I hope you really understood the method. First, we are simply finding the difference. Then we are simply adding the squaring those differences. Then we are adding those differences, and then we divide, right? So I think I have an answer. Okay, right. So our answer here is 23.89. This is not the spread, right? This is the square of the spread, the standard deviation. 23.89 is the variance. And now if you want to find the standard dev, we simply square root it, right? 23.89. Now I will square root it and let me tell you the answer. Okay, it is 4.9, 4.89. Okay, so 4.89 actually means that your data is spread by 4.89. If I say how much data will be covered in two standard devs, so what are you going to do? 21.67 plus 2 multiplied by 4.89, 21.67 minus 2 multiplied by 4.89. That from that value till this value, we cover two standard devs. Okay, so I hope this is clear. This we have only now discussed mean and standard deviation and variance. Now mode is very simple, the most repeated value, right? And in this case it is 19, right? And for median we need to organize it in ascending order. So 14, 19, 19, 27, oh sorry, 23, 27, 28. I think I've written the 6 values. Yes. So n plus 1 upon 2. Now, n is the number of values. So that is 6. 6 plus 1 upon 2. Always remember this for median. So 3.5, you get your answer. This is not your median. This tells you that 3.5th value will be the median. Okay. The 3.5th value is the median, right? So that is between 19 and 23, right? And that comes out to be 21. So our median is 21. Okay. We will come back to this question for range once we discuss what range is. We have already discussed what standard dev is. So that is obviously going to help in that. Okay. And interquartile range as well. Okay. First, we discuss how to choose the best measure. We have already paid a little attention on this to the simulation, but let's do it properly. Okay. So it really depends on the data set. There are certain advantages and disadvantages. Mean has an advantage that it uses all data values. So it's really good for large data sets, right? Where the values are, close together. So, but if there are extreme values, mean will be distorted. So then no mean. Median will not be affected by high extreme, low extreme values. And mode is very useful, but there can be situations and when there is one more than one mode, no mode, or even a mode that is, nowhere near the middle of the data set. Again, extreme values ki wajah se aapka mode impacted, or we discussed that, right? So these are some of the few things. Now let's go towards the quartiles and percentiles, right? Okay, I'll make a diagram for you to understand this. Then it would be easier to understand the concept, right? If this is, let's say, your Q2, and let's say this is your Q1, and let's say this is your Q3. That means 25% of the data lies here. 25% of the data lies here. 25% of the data lies here, and 25% of the data lies here. Now see, what I actually mean to tell you is that from the median is your quartile 2, right? From the median, 50% of the data is above the median, 50% of the data lies below the median. 14 values हैं, 7 are above, 7 are below, right? For quartile 3, 25% are above quartile 3 and 75% are below quartile 3. That is your upper quartile, right? It splits between 75 and 25. And quartile 1, 25% values are below quartile 1, your lower quartile, and 75% are above. And now if there is a percentile, 70th percentile, let's say, so 70% of the data is below it and 30% is actually, above it. And that would be 70 upon 100. Okay. Right. Let's move further. Okay. All right. Now, how do you calculate the quartiles, right? N upon 4. N is the size of your data set. So to find the lower quartile, you do N upon 4. Okay? And then you will round it up to the next integer. You never round it down. Even if it's 3.2, it will be rounded to 4. Even if it's 3.6, it will be rounded off to 4, right? We will see an example. And for upper quartile even, it's 3n upon 4 and you will round it up, okay? Right? And for median, we discussed n plus 1 upon 2. So that you do not need to, round it up actually. For upper lower quartile, this is what I would tell you. Okay, range is basically highest minus lowest value, and interquartile range. Both of them are measures of spread, just like variance and standard def. But interquartile range is upper quartile minus lower quartile, right? Okay, we will go to that same data set and let's find the range. Okay, first we are going to find the range. So range, again, your highest value is 28, your lowest value is 14. 28 minus 14, right? That is 14. Yes. And we found the median. I think, I don't remember. Yeah. I think I do remember now. The median was 21. Let's look at it again if that's not an issue. 14, 19, 19, 23, 27, 28. Yes, it was 21. Okay. Now we will look at the upper quartile and lower quartile. So there are 6 values, 6 upon 4. We were rounding it up, if you remember, right? So that is 1.5. 3 upon 2, 1.5, round up 2. This is your Q1, right? And then it was 3n upon 4. That is 3 into 6 upon 4. 3 over 2. 4.5, fifth value, basically. This is your Q3. And your interquartile range would be, the IQR would be 27 minus 19. 8. Right? So we have done this topic. We understood all with basic data sets. Inshallah, we're going to do these with, complex data sets, even when you get frequency tables. I would highly recommend you go and practice one question on your own so that you make sure you understand. If you have any questions, please do write them in the comments. Thank you.